We had some technical difficulties when we were filming earlier, so we're trying again this evening. Unfortunately, you just missed the 4 deer that were in our yard. We tried to get a video, and if it came out okay, I'll put that up on the YouTube channel. But this says let's talk, and the date is Monday, the 30th. You probably won't be seeing this until Tuesday. But let's go over some things. Survey. We're going to have the last day for people to answer the survey be on Thursday. We currently have 42 out of 57 kids. So if you're talking to any of your friends, ask them if they filled out the survey. And then probably on Friday, I'll compile all the information, and then starting next week, we'll start working on our line plots. Today we're going to go over last week's calendar grid, and then I will send all of the following week, which is week 4. I will send those pictures to you, and you can fill out week 4 on your own. We will be going over it then the following week. Trivia is due on Thursday. I sent a list of the rules. For the most part, it's the same as it is in school. It's due Thursday by 3 o'clock. And then Friday, I will videotape me choosing the winner from each class. Remember, this time there will only be one, even if that person has already won. And I will be going over how that person solved it, and if there's any other methods that I really like, or that I really think that you would find interesting and could use on other problems, I will put those up as well. I hope you enjoyed doing the Mathological Liars. Addie created a case on her own, and I sent that to you. And now Audrey has one that I'm sending to you. That will come probably with this videotape, so if you want to try Audrey's, there's a few others that are coming that I will send along. And remember, it's a good way to practice by writing your own and sending them to me so I can share them with your classmates. Today, after we go over last week's calendar grid, we're going to review volume, and so you'll need your journals to do that. Find the page in your journal that reviews what volume is and the formulas to find it. And then I'm going to show you a cool website from NCTM, which is a math group that has put some fun activities online. And this one with volume really helps to cement what volume is. And you can try some of those on your own. So let's get started. We're going to go over last week's calendar grid. Some of you have sent them to me, and I see that you're following the patterns, which is great. And I'm going to be asking you to really look at the mathematical patterns as we go through this and try to use those mathematical patterns to solve next week's. So this is week 3. The calendar grid. Okay, just quickly going over on day 11, which was the first day of that pattern, we had 126 times 304. We estimated that to be 120 times 300. And the reason we chose that estimate is because we knew very quickly that 12 times 3 is 36, and then we needed to move up 3 place values. Since 36 was a whole number, the way we move up place values is to stick those zeros on the end. And then we found out that our actual was 38,304 square units, and we refer back to our estimate. Is that close? And the answer is yes. So it is probably the correct answer. We know for sure it's correct, but you always want to look at your estimate. Your estimate should be the thing you base it on, because this is the easy problem. This is the more difficult problem to solve. Okay, then we went to day 12, and we noticed that the first factors were the same as the first expression, but that the second factor, although they had the same digits, it was 1 place value less. Then when we did our estimate, we chose 120 again, and then this became 30 because remember it's one place value less than 300. 12 times 3 is 36, and we moved up 2 place values. Then there were 2 ways that we could have figured out what the answer to this expression would be, and that was, we knew that it had to have, because these had all the same digits, just different place values, these would have all the same digits, just different place values. Since this was only one place value different, we knew our product would be one place value different. That's the first way we could find it. The second way we could find the answer is to look at our estimate. If our estimate is 3,600, putting the decimal point there is the only way it makes sense. If we had put the decimal point anywhere else, it would be too far away from our estimate. Okay, so let's move on. Hopefully that you had an opportunity to do these. I'm just going to grab another color pen. And so now it's 12 6/10 times 304. We go back to our original expression. We see that this is one place value less than this factor, and this is the same as this factor. And we have to decide what is our estimate going to be, and it makes sense for this to be 12 times 300. Okay, now if we were estimating by using rounding, this would actually be 13. But remember, you don't always have to estimate by rounding. What you want is to get a quick and easy answer. And 13 times 3, most people that don't know. But they do know 12 times 3. And 12 times 3 is 36. And then we have 2 more place values to increase that. And so again, we get 3,600 for our estimate. Now we have to figure out what the actual answer is to this, and we know that it's going to have all the same digits. So that's what I do. I just write down the digits. No commas, no decimal point. I just write down the digit. And then I look back at my expression. Okay, so 12 6/10 is one place value less than the original expression, and 304 is the same factor as 304. So there's only one place value difference in the expression, so there will be one place value different in the product. So we start from here and we move over one place value, and we put our decimal point in, and then we count over 3 so that we have our comma. So our answer becomes 3,830 and 4/10. And then again, because we're talking about area, we're doing square units. If we didn't use our place value differences, we could also just look at our estimate. And again, we see that the estimate is 3,600, and that is the only place that it would make sense for 3,830 and 4/10. Because if we had put it here, our answer would be 383 and 4/100. Well, that's nowhere near our estimate of 3,600. So again, when we look at this, we see that there was one place value less from the original expression, the original whole number expressions. Okay, let's move down to the next one. 12 6/10 times 3 4/100. So if I'm looking at that, I want to estimate that to be 12 times 3. And we already know that 12 times 3 is in fact 36. I'm going to move this up a little bit higher so that I don't have to bend down so low. 12 times 3 is 36. That's a fair estimate because we look at 12 and we look at 3, and those are easy numbers for us to multiply together, and so that makes a good estimate. I also know that these have all the same digits in their factors, they just have place values less. And so I'm going to write all the same digits that were in my original answer, and that would be 38304. I'm going to leave out all the decimal points and the commas until I figure out what makes sense for the answer. I see that 12 and 6/10 is one place value less than 126. And I see that 3 and 4/100 is two place values less than 304. And together, that means that our product has to be 3 place values less. And so in order to do that, I start at the end of the number and I move over 3 place values and put in my decimal point. And then because we were still working with area, I have to have square units in my answer. So I got my final answer to be 38 and 304 thousandths. I compare that to my estimate and it does indeed make sense. So I've gotten the correct answer. And finally we go down to 3 and 4/100 times 1 and 26/100. So I look and I want my estimate to be 3 times 1. Certainly easy enough. 3 times 1 is 3. Now I have to do the actual. I know that these have all the same digits as the original expression. So I know that my actual answer is going to have all the same digits. I write them in, 38304. Now I can find out where the decimal point goes by simply looking at my estimate. If my estimate is 3, it only makes sense that the decimal point would go here. And my answer would be 3 and 8,304/10,000. And now I don't put in my square units because if you remember, the pattern says the last one is just an expression. It is not looking for area. And the other thing that they did in the last expression is they switched the factors. You'll notice up here it was 126. Those 3 digits are now in the second factor. The first factor here is 3 and 4/100. Those same digits were in the second factor, 304. It doesn't matter though because multiplication has the commutative property which says we can switch the factors and still come up with the same answer. But that's something that they really wanted you to notice in the pattern, that the last example in the pattern switches the factors around. Okay, so we have 3 and 8,304/10,000, and we can see that this was 2 place values less than the original whole number expression, and this one was also 2 place values less. And so that means that our answer is going to be 4 place values less than the original expression that was given up here. So that's how we figured it out. Now let's take a look. Let's try to remember some of the patterns that you came up with for weeks 1 and 2 and see if they still hold true. Well, one of the patterns somebody said was that it was whole number, 1 place value less than the whole number expression, 1 place value less than the whole number expression, 3 place values less than the whole number expression, 4 place values less than the whole number expression. So that pattern held true in the 3rd week. They followed that same pattern when they gave these expressions over here. Somebody else said that we were looking at a horizontal rectangle where the longest length ran horizontally, and then a vertical, and then a horizontal, and a vertical, and then just the expression. And that held true. Somebody also said that every fourth card in the pattern was blown up, and that was true for this one, because in order for them to show a rectangle that only had an area of 38 and 304 thousandths square units, they had to blow it up. The grid wasn't big enough. So all of the patterns that you came up with in the last video still hold true for this. Something to keep in mind and something to take a look at when you are trying to solve week 4's calendar grid, which will be coming at the bottom of this email. So enjoy it. Keep trying to find those mathematical patterns, and we'll discuss them next week. Thank you.